Welcome back to my series of doing simple programming tasks. I've been looking at Project Euler problems, and going numerically from the start I'm now at number 6. Here they ask us to compare summing numbers and then squaring, to squaring first and then summing, and they want to know what the result is if you subtract one result from the other. I know there is a mathematical formula for the sum of squares, but I don't remember it, and since this is such a small and easy problem, I'll just do this the brute force way. There is a funny story about the formula for sum of numbers. A famous mathematician, Carl Friedrich Gauss, at one time when he was a kid, made his teacher annoyed. To keep little Carl Friedrich busy, the teacher told him to sum all the numbers from 1 to 100. That should keep the boy busy for a while, the teacher thought. Instead, Carl Friedrich made some quick calculations in his head and proclaimed the answer, 5050, shocking his teacher. The story goes on saying that the teacher then asked him to sum the numbers 1 to 1000, and little Carl Friedrich answered as quickly as before, 500,500. So the formula for summing numbers is quite simple. The formula for summing squares and numbers is slightly more complex, and I might put it up on the screen where I edit the video, but here let's just loop over all numbers, add the numbers, and add the squares. One thing that makes the programming language Python good for these problems is that Python has no size limitations on numbers. Many programming languages have numbers that can only be certain sizes so that they can use the most efficient CPU instructions. Python, on the other hand, is a bit slow, as programming languages go, but it will allow us to work with any sized number. In this case, it means that I don't have to worry about the square of these sums or the sum of these squares being too large, something that might have been a problem in some other programming languages. So we let the program loop over all the numbers and add all the numbers to one variable and all the squares to another variable. In the end, we'll subtract one from the other and we have the answer. First, the example problem, just to verify that our program seems to work. 2640, just as the problem text says. Great. Next up, the full problem, all 100 numbers, and the answer is 25,164,150. And since the problem was so small, even the brute force solution was more or less instant. So let's check what the numbers involved were. As you can see, the square of the sum is much larger than the sum of the squares. So see you next time for another Project Euler problem.